Hi, we're Elsa and Olivia.
And today we're going to be talking about percent yield.
Overview of percent yield. The percent yield value tells us how complete a chemical reaction is. The percent yield is the value of real reactants that actually turn into products in a lab. In most real-life chemical reactions, not all of the reactants are used because of performance errors or side reactions that can occur, which inevitably affects the amount of product created.
Percent yield formula. Begin with taking the actual yield from your chemical reaction, which is the quantity of the product obtained from a chemical reaction, and put it over the theoretical yield, which is the quantity of product obtained from a complete conversion of the reactant in a chemical reaction. Then that should give you a decimal, so then you multiply it by 100 to give a percentage, which ends up being your percent yield. Percent yield is the measured efficiency of a chemical reaction.
And 100% yield is called reaction efficiency.
So here's the fun example that Elsa and I created. In Mrs. Milstad's 5th period class, there are 30 chemistry students. Oftentimes, however, not all of the students are present. One day, Elsa and Olivia decided to be truants and skip class. What is the percent yield? So in this case, the actual yield would be 28 students because typically there's 30 and 2 are missing, so we get 28 students as the actual yield. You divide that by the theoretical yield, which in this case is 30 students. Then you multiply that by 100 to change it to a percentage, and you get that the percent yield is 93.3%.
Obtaining the theoretical yield. If 4.5 grams of barium sulfate are reacted with an excess of carbon, 1.86 grams of carbon monoxide are obtained. The balanced equation reads as barium sulfate plus 4 carbon goes to barium sulfide plus 4 carbon monoxide. Starting with 4.5 grams of barium sulfate, then you multiply by 1 mole of barium sulfate over 233.39 grams of barium sulfate. This converts your barium sulfate from grams to moles by dividing by the molar mass. Then multiply this by 4 moles of carbon monoxide over 1 mole of barium sulfate, using your balanced equation to convert the moles of the reactant to the moles of the product. Then multiply that by 28 grams of carbon monoxide over 1 mole of carbon monoxide to convert your moles of product into grams by multiplying them by the molar mass. This equals 2.16 grams of carbon monoxide, which is the theoretical yield of your product. Final answer, finding the percent yield. Using the percent yield formula, divide by the given actual yield by the theoretical yield, and then multiply by 100 to convert from decimal to percent. So starting with 1.86 grams of carbon monoxide, you divide that by 2.16 grams of carbon monoxide because that's the theoretical yield. Then you multiply by 100 to end up with an 86.15% yield.
Here's another example. In a certain experiment, 40 grams of potassium chlorate is heated until it completely decomposes. The experiment is performed and the oxygen gas is collected and its mass is found to be 14.9 grams. What is the percent yield for the reaction? Okay, so what's important to note here is that we have 40 grams of potassium chlorate, and then we also are looking for the theoretical and actual yield of oxygen gas, which and the actual yield is 14.9 grams in this scenario. And the equation that we have here is potassium chlorate into potassium chloride plus oxygen gas. Here's the answer to that problem. So the first step is to balance the equation, which in this case should be 2 potassium chlorate into 2 potassium chloride plus 3 oxygen gas. The second step is to find the theoretical yield using stoichiometry. So you would take 40 grams of potassium chlorate and multiply it by 1 mole of potassium chlorate over 112.5 grams of potassium chlorate, then you multiply that by 3 moles of oxygen gas over 2 moles of potassium chlorate, and multiply that by 32 grams of oxygen gas over 1 mole of oxygen gas, which is equal to 15.7 grams of oxygen gas. So that's your theoretical yield. The third step is to use the actual yield and the theoretical yield to find the percent yield. So you take 14.9 grams, which, like we said from the other slide, this is our actual yields in this scenario. And you divide that by 15.7 grams of oxygen gas, which is what we just calculated. You multiply that by 100 to convert it into percent, and that equals 94.9% yield. And then our real world connection is the pharmaceutical industry. Lots of money is spent in the pharmaceutical industries trying to increase the percent yield so more product is created to sell. It is important for pharmacists to maximize percent yield so less money and resources are wasted.
That's good.